Today, we're going to talk about classes, making objects from classes. There's going to be a lot of review, but there's also going to be a lot of new things. We have been working with classes since the first week of school. We've been working with object-oriented programming since the first week of school. Today, we're just going to formalize what a class should look like and how to create our own classes. We're going to do this in NetBeans. Most of what we've done with classes, with few exceptions, has been a combination of Greenfoot, because we can actually see our classes or the objects that we make from classes in there. It makes for a little bit of better understanding. But today we're going to be a little more abstract. We're not going to actually see our objects. We're just going to create them in memory and ask them to do things. And we've done similar things to that in the past, but we're going to formalize more than anything the Java class structure. How do you structure a class? What's the standard way that most programmers structure their class? So we're going to create a new project and Java application, and I'm going to call this my dog demo because we're going to create a dog. So here's my class. Now the first thing we want to talk about is the main method. The main method, this class that holds the main method, this is our driver class. This is the class that drives our program, but this is not where we should be doing most of our programming. If we want to create a dog simulation, we should write the dog in its own class. And we can use the main method then later to instantiate or create that dog in memory. So let's start by saying File, New File, and we'll pick a Java class. And we'll call this class Dog. And now we have two classes inside this package. We have dog.java, which is going to be our dog class. And we have the dog demo, which is the driver class. The driver class is going to create dogs in memory and ask them to do things. So, what do we have? A dog. What is a class structure, first of all? Let's talk about that first. We have properties. I want to make just a little note here. Generally, our class should start with our properties. And I need to spell it correctly. And then our behaviors come after that. And we already know our behaviors are our methods. Properties followed by behaviors. So what are the properties of a dog? Well, for this simulation, we're going to say a dog has a name. Now, in general, there are some principles we follow when we create a class. And one of the principles is encapsulation. And encapsulation says that people should not be able to directly access our data. So, when we create our properties, we generally create them as private variables, private properties. We don't want people to, other classes, and when I say people, I mean other classes. We don't want another class to be able to come in here and change the value of our private variables. If we want to allow people to change them, we'll give them behaviors later on that let let other classes change it, but we can write code in there to make sure they change it in the way we want it to be changed. So for our dog, let's give him a private variable called name. And name would be a string. So our dog has a name. And our dog also has, let's do an int to store the dog's age. And we'll leave it at that. I don't want to make this class huge. So we'll just do a couple properties. One is a string, one is an int. let's go create a dog. Let's go back to our driver class. Since we have a dog class now, I'm going to go ahead and save it. I'm going to go back over here to my dog demo. How do I create a dog? How do I instantiate a dog? Well, we've done this before when we want to create objects. When we've created the scanner class, when we've created scanners to scan things in, we've created random number generators in memory. You created a compute methods project, and you created that compute methods class in memory, so you could call its methods. We've done this quite often. We've done it in Greenfoot, where we create all of our new game objects. We create them in memory, and every single time we use the new keyword. So how do I create a dog? I simply say new dog. And that creates my dog for me. Okay. However, we need a reference to that dog. So my reference is a variable. And it's a variable that points to that object in memory. So what kind of variable is it? What kind of reference is it? What's it going to hold? It's going to hold a reference to a dog, so its type needs to be dog. So I'm going to create dog, and I'm going to call this dog Fido. Now that's my variable name, Fido. This is my dog. I create my dog in memory, and I assign it to this reference variable called Fido. Now we have a dog. It's in memory. We have this Fido. What does our dog do? It doesn't do anything. It can have a name. It can have an age. But we've already made those private, so we can't set them. If I run my program, it doesn't really do anything. It runs. It creates the dog in memory, and then the program ends. What if we tried to look at some information about our dog? Let's look at Fido dot age. Let's say statement. Let's print out Fido dot age. Do that. Age has private access. Excuse me. So from this class dog demo, we can't directly access the dog's age because private. If I changed his age to public, I changed the dog class so that the age was public and went over here, I have no problems. My error just went away and I can access my dog's age. In this case, it's 0 because we never actually set the dog's age, and by default, it gets set to 0 when they're declared. But I already said we don't want this to be public, so we'll make it private. And we will come back in the next video and solve this problem that we cannot access the properties of our class. We'll talk about how to set them initially when we create our dog, and we'll talk about the proper way to access them.